Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Bismillahirrahmanirrahim. Wa bihi nasta'in, la haula wala quwwata illa billahil aliyyil azim. Apa khabar pelajar-pelajar sekalian? Semoga semuanya dalam keadaan sihat walafiat. Hendaknya diucapkan selamat datang ke kelas Kimia Perayu Stpm matrikulasi. Alhamdulillah, bersiaran lagi kita dalam kelas tuition online PERCUMA AYU yang dibawakan oleh Akademi YouTuber dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Sebelum kita mulakan kelas pada malam ini, bolehlah kiranya kita mulakan dengan bacaan Ummul Kitab, Al-Fatihah. Pelajar-pelajar, guru-guru dan ibu bapa yang dikasihi sekalian, saya perkenalkan diri saya dahulu. Nama saya Cikgu Shahnon, selaku moderator pada malam ini. Kini kita sedang bersiaran dari channel Vivi Lau, channel hak milik bagi Cikgu Lau Chaiwi. Cikgu Lau akan mengajar kimia yang bertajuk Electron Transition dan akan bersiaran selama lebih kurang 1 jam. Selain itu, di konti kita juga ada Cikgu Yun Tang, alias Cikgu Tang, yang bertindak sebagai control host. Tidak dilupakan Cikgu Li hati. Sebelum kita mulakan kelas pada malam ini, ingin saya ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, hendaklah menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tatapan umum. Sila fokus pada isi pelajaran yang akan disampaikan oleh Cikgu Lau dan hanya menggunakan ruangan chat untuk mengutarakan soalan dan kemuskilan, serta jika diberikan soalan, sila jawab pertanyaan dengan pantas. Juga diingatkan, link sijil penyertaan akan diberikan di penghujung kelas pada malam ini. Sila ambil perhatian, link tersebut akan tamat tempohnya setengah jam selepas sesi berakhir. Sijil hanya dapat diakses melalui email e-didik sahaja. Kepada yang belum mempunyai email e-didik, silalah daftar dengan merujuk di Telegram e-didik junior. Para pelajar, guru-guru dan ibu bapa sekalian, tanpa melengahkan masa lagi, majlis dengan segala hormatnya mempersilakan Teacher Lau untuk memulakan kelas. Dengan segala hormatnya mempersilakan.
Thank you, Cikgu Shannon, our moderator today, for the awesome intro. Thank you, Teacher Im and Cikgu Naini as observers today. And last but not least, thank you, Teacher Tang, as our control host today. Hi, everyone. Good evening, students and teachers, for attending the class today. Welcome to my channel. Let me introduce myself first. So my name is Lau Chaiwi. I'm teaching in Pusat Tingkatan 6 SMK Pendidikan. My teaching experience is 19 years and my YouTube channel is Vivi Lau. Now I would like to introduce my PU teammates. So we are a group of teachers. They created a PU lesson collab team YouTube playlist. You can visit the playlist via this link. Later I will put the link in the description. Okay, so first we have PU mathematics teams. So you can see here we have Teacher Im that teach Mathematics T. So she is our Ketua Panitia for the PU group. And we have teacher Eileen. She also teach Mathematics T. Next we have Cikgu Zana. She is teaching Mathematics M. Okay, next one. We have PU Biology team. So as you can see here, we have Cikgu Faiza as the chief of the team. And next we have Cikgu Fatia and Cikgu Naini, which is our observer today. Okay, then we also have accounts that is led by Madam Fizi and Cikgu Yati as a member. Last but not least, we have chemistry team. So our chemistry team is led by Cikgu Shannon. And then we have members consist of the teacher Tang. So Cikgu Shannon is the moderator today. Teacher Tang is the control host today. And we have Cikgu Mawa and me, teacher Vivi Lau. You also can go to the website www.academyyoutuber to know the to access the timetable for the online class. Okay, so let's begin our lesson today. So today I'm going to talk about atomic structure. So it's in the chapter 2 Stpm chemistry. There is electronic structure of atom. Okay, today I will focus on subtopic electronic energy levels of atomic hydrogen. So specifically on the on the Bohr model of hydrogen atoms. Okay, then the learning outcome for today's lesson is to explain the formation of the emission line spectrum of atomic hydrogen in the Lyman and Balmer series using Bohr's atomic model. Okay, so let's look at Bohr model of hydrogen atom. So this is Niels Bohr. So Niels Bohr is a Danish scientist. He suggested a model of the hydrogen atom that predicted the existence of line spectra. So you can see here. So first let's see, we have atom. You know that we have atom. So atom consists of nucleus and electron. So in the nucleus we have proton and neutron. Okay, so Niels Bohr will explain the Niels Bohr have explained the line spectra using his model. Okay. So according to Niels Bohr, the electron must have fixed energy, must have specific energy levels. Okay, so the electron move on the specific energy levels, or we call orbits. Okay, so the electron can be located at the energy level 1, energy level 2, or energy level 3. So the n is a principal quantum number. Okay, so Niels Bohr also suggested that the electron will release energy when it falls back to the lower energy level from the higher energy level. So the energy is released as a electromagnetic radiation. Okay, but it's not continuous spectrum, it's a line spectrum. So let's look at the difference between continuous spectrum and the line emission spectrum. So continuous spectrum is like the rainbow. So you can see it's a very smooth spectrum. But however, the line emission spectrum, it has a fixed lines, okay, with a specific amount of energy. So we call quantized, okay. So you can see here the difference. So continuous spectrum has a range of broad range of wavelengths, but for the light emission spectrum, it has a specific frequency or wavelengths, so it appears as lines. Okay, so the energy is also wide range for the continuous spectrum. For the light emission spectrum, it has fixed amount of energy. So there is no energy in between the energy levels. Okay, so the continuous spectrum is very smooth, okay, and continuous, like the rainbow, okay, white light. Light emission spectrum is just have the specific lines and not continuous. Light emission spectrum normally is emitted by the atomic hydrogen for the Bohr models, okay. So now we go back to the Bohr models, okay. So Niels Bohr has suggested a three important points. First one, the electron can only have certain discrete energy level. So this energy level is called a quantum number, okay, or principal quantum number. So the electron can be at the energy level 1, energy level 2, and energy level 3, but cannot have any energy in between the energy levels here. So this is almost like the radar. So the electron can move from one step of the ladder to another step of the ladder, but you cannot see any electron at the middle in between the ladder steps. Okay, then second point, when sufficient energy is supplied to the atom, electrons jump up to a higher energy level. So we say the electrons is excited, or the atom is excited, okay? So you can see here. So the electrons from the energy level 2 when you absorb enough energy, it will be promoted to higher energy level. Then we say the electron is excited. Okay, then the excited atom will emit energy in the form of electromagnetic radiations as the electron falls back down to the lower energy level. Okay, so the excess energy it will emit as the electromagnetic radiation, or we call it as photon. Okay, so the energy is equal to Hf, the formula. Okay, so this energy, each electronic transition, we call electronic transition for the electron movement from higher energy level to lower energy level. Okay, each electronic transition will have specific lines formed at the spectra. So you can see when the electron falls from energy level 3 to energy level 1, light is emitted, and you can see the line on the emission spectrum. Okay, one line at the emission spectrum, and the next line is formed when the electron move from the energy level 2 to energy level 1. Second line is formed. Okay. So each line in the emission spectrum here, this is the emission spectrum, is correspondent to the electron force. Okay. Because when the electron falls from the higher energy level to the lower energy level, it will emit light. So we call the spectrum emission spectrum. Okay, so each one have a specific frequency. Yeah. Okay, the relationship between the energy of a quantum of radiation and its frequency is given as in the Planck equation shown here. So this is a Planck equation. So delta E equal to h nu. You can write nu or f. So it stands for frequency. H is the Planck's constant. Okay, so here shows the value of Planck's constant. So it's 6.63 times 10 to the power of negative 34 joule second per atom. Okay, so normally we need to find the value in mole. Okay, normally energy we use kilojoule per mole. So we have to multiply by Avogadro constant, 6.02 times 10 to the power of 23. So you will get 39.91 times 10 to the power negative 11. So joule second per mole. Okay. So multiply by frequency, then you will get kilojoule per mole. Divided by 1000, you'll get kilojoule per mole. Okay, so let's look at the energy level again. Okay, so you can see here there are two electron transition here. So first one is the absorption and second one is emission. So when the electron at the ground state is stable, ground state is energy level 1, n equal to 1. So electron will move up. When absorb enough energy, it will promote to a higher energy level 3. But here it's unstable, so it tends to fall back. So it falls back and form the emission spectrum. Okay, fall back to the ground state, n equal to 1. Okay, so you can see here the energy emitted is equal to E3 minus E1. So you can calculate the E3 here minus the E1 here is the energy reference. Or straight away use the Planck equation. Delta E equal to h nu hf. Okay. So each photon released contains a quantum of energy with a certain frequency. Okay, so nu is a frequency. The frequency corresponds to a specific line in the spectrum. Okay, so far any question from the student? Cikgu Shannon?
No, not yet. Not
No
yet.
question yet. Okay, so I continue. So we look at this one. Okay, so pay attention there when you draw the light emission spectrum. So as the energy levels get closer, energy level increases. The separate lines in the series will become closer together as the frequency increases. Okay, so the lines will become closer together. Okay, so now we look at the first question. So students can write your answer in the comments. Okay, so let's look at the question. Which of the following explains why the emission spectrum of hydrogen is a line spectrum? So the question is very easy. So we
Okay,
have
student.
First answer is the electron in the hydrogen atom can only reside in certain energy levels. Second answer is the spacing between the energy levels gets closer with increasing frequency. Third answer is the electron radiates energy when it drops to a lower energy level. Then the fourth answer, the single electron in the hydrogen atom moves around the nucleus in fixed orbit. So which is the correct answer? Students, you can write your answer in the comments.
Chung Zuo Min, answer is A.
Oh, okay, very good. So the answer is correct.
Hans also A.
So how many answer correct?
Soba sini A. Okay.
Very good. Okay.
Majority of them.
So the electron in hydrogen atom can only reside in certain energy level. So that's why it has a fixed frequency, and the spectrum is a line spectrum. And the electron is quantized. Okay. Now let's continue the Bohr model. So for the Bohr model, Niels Bohr explained how the series is formed. Okay. So his formula is fixed perfectly for the spectral lines. Okay. So we have three series shown here. Okay. We have Lyman series, Balmer series, and Bastian series. Okay. So you can see here for the Lyman series, the electrons will fall back from the higher energy level, fall back to the ground state at n equal to 1. Then Balmer series is electron falls back to n equal to 2. Bastian series, the electron falls back to n equal to 3. Okay. So Lyman series has a higher energy, so it's located at the ultraviolet region, so we cannot see the ultraviolet light. Okay, so higher energy, so ultraviolet is dangerous to our skin. Okay, then we have Balmer series, which is located at the visible region, visible light. You can see this one. Okay, then next one, Bastian series is in the infrared region. Okay, so you can see look at the Balmer series one. So when the electrons falls from the highest energy level here, n equal to c, show here, n equal to 6 falls back to n equal to 2, you will get the first line here. So 410 nanometer, so it's a fixed wavelength. Okay, so fixed frequency. Then the second line falls from n equal to 5 to n equal to 2. Okay, so 434. 234. Then next one from n equal to 4, okay, falls to n equal to 2. So 486 nanometer. Then last one, the smallest difference. We have n equal to 3 falls back to n equal to 2. Okay, 656. So this is a normal series. Okay. Okay, so the next diagram will show the electronic transition. Okay, energy levels of the electronic transition, which produce lines in the Balmer series. So you have to know how to roll the energy levels of the electron transition. So you can see here. So when you roll the energy level diagram, you have to make sure the electrons falls back to the ground state is 2. Okay. Okay, so The line just now is 6 to 5, 6 to 1. So the first line just now is 6 to 2. Okay, 6 to 2. First line, second line, 5 to 2. Okay. Then 4 to 2 and 3 to 2. Okay. If the energy is enough, we have electron force wave from the infinity. Then you form a continuum. So the frequency here is the convergence of limit. We can use this one to calculate the ionization energy. So the frequency is called convergence of limit. Okay, so as the frequency increase, the lines getting closer. Okay, so make sure you roll the lines getting closer at the high frequency and corresponding to the higher energy level. Okay? Higher energy level transition. Okay, so pay attention to this. So the energy levels are number 1, 2, and 3, and so on. So these numbers are referred to as quantum numbers or principal quantum numbers. Okay, then the colors of the visible regions of the hydrogen spectrum are caused by electron transition from higher levels to the level n equal to 2. So for Balmer, you must roll to n equal to 2. So if Lyman series, you have to roll to the electron force back from higher energy level to n equal to 1. Okay, so Balmer is 2. Okay, then the one, as the energy levels get closer and eventually comes together, it follows that the spectral lines also get closer and eventually comes together. So we merge, the lines will merge together. Okay. So now we look at the series again. Okay, so Lyman series, the ground state is 1, normal series 2, Gaussian the series 3. Okay, so the N2 is the second energy level, higher energy level. So for Lyman is 2, 3, 4. Normal is after 2, 3, 4, 5. Gaussian is 4, 5, 6. Okay, so Lyman is at the ultraviolet range. Then Palma is the visible range. Gaussian is at the infrared range. So you have to memorize the region. Okay, range or region. So Lyman is in the higher frequency region. So higher energy level, higher energy. Okay, so followed by Balmer and then Gaussians. Okay. We also have other series, but you don't need to stress that in the Stpm level. Okay. So we have P-Fan and Beckett series. Okay, now question 2. So which of the following diagrams best represent the line spectrum for hydrogen atom in the visible light range? So students, please answer this one.
Visible light range. Okay, student.
So visible light range, students.
We have Haras now. Haras A.
Yeah, okay. So any other answers?
Bun Long Lim B. and
B.
then harus change to B.
Change to B.
Zijintai, Subashini also B.
Okay.
Xiao B, Goh Yuk Long B, Nur Amirah Balkis B. Many of them.
Okay, so very good. So the answer is correct. B. So the question mentioned visible light range. Okay, so you have to only write one series. Okay, so the answer, most possible answer is either B or D, but B has two series.
Yeah.
But here only mentioned visible light only. You can write one series. Okay, so highest
Okay.
N has a line merged together. Okay.
Okay, teacher Vivi Lau, maybe we have to take a break.
Okay,
Yeah.
thank you. Let's take a break.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay, teacher Vivi Lau, you can continue your lesson.
Thank you, Shannon. Okay, so welcome back, students. So just now the answer is B, because the question mentioned visible light range. So you only can choose one series. Okay, cannot choose a D. D has two series. Okay, so the high frequency N must have the lines merged together. Means the difference between the lines will getting smaller and smaller. Okay. Okay, now we look at question 3. Okay, so which of these electron transitions in the hydrogen atom has the longest wavelength? So anyone want to answer this question? Write in the comments.
Maybe you can give a clue about this question.
Okay, so longest wavelength. So when the question say longest wavelength means, so wavelength is formula is F equal to C over wavelength length. So when the wavelength is longest means the frequency will be lower. Okay, wavelength longer, highest wavelength frequency lower. So E equal to HF, right? So when the F lower, the E will lower also. So what do you think is the answer?
Chong Sing Chua, the answer is C.
C.
Arasi, Muhammad Iqbal C. Kristita Murali C. Bunlong Lim B. Dari sini Satya C.
Okay, so most of the student answer C. Okay, so yes, any other answer? So any others answer, Cikgu Shannon?
C, B and C.
Okay, B and C. So let's check the answer. So the answer should be A. So remember that the energy level will getting closer, okay, as the energy increases. Okay, the energy will getting, the spacing between the energy level get closer. So means the energy response will become smaller. So you must choose the highest one. So N equal N5 to N4. Okay, if you choose N2 to N1, it's very big. The energy difference is very big. Okay, you can see here. This energy difference is very big. So you must choose between the 5 and the 4. Okay, 5 and 4.
Remember that the wavelength and frequency is inversely proportional.
Yeah, you see, wavelength and frequency is inversely proportional. So when the wavelength is higher, onwards wavelength, you have the lower frequency. Okay, so lower frequency means the energy is smaller. So we have to choose the smaller difference in energy. N5 to N4. Okay. Now we look at next question. Question 4. Calculate the number of lines formed for electron transition between N2 equals to 5 and N1 equals to 1.
Okay, how many lines?
Okay, so means how many lines involved in the electronic transition between N2 is 5 and N1 is equal to 1.
The clue is maybe you can draw the line, right, from 1 to 5, and then draw the line form. Is it right? Vivi Lau?
Okay, so I give you the clue. So you need to roll the lines. So they mention 5 and 1.
How many lines? We have
to
5 lines. We have 5 energy level. How many lines?
level. Okay.
We have 5 energy level. Energy level 1 until 5.
3, 2, 1. Okay, so you have to roll. Okay. So try to roll yourself, students. So let's say first one 5 to 1. So you will get 1 line. Okay. 1 line is the spectrum. Okay. Then you roll the other. Okay. So actually there's a formula for it.
Muhammad Iqbal, 4 line.
4 lines. Okay.
Gomi, 4 line. Bun Long Lim, 4 line.
Okay, very good. Okay. So any other answers?
Any other answers? 10.
Your student answer 10 lines.
10 line.
Oh, that's a lot. Okay.
Chung Zuo Ming, is it all series?
Huh?
All series. Is it all series?
What's on series?
The question number 4. I think the question is quite simple. Calculate the number of line. That means number of line between n equal to 5 and equal to 1, right?
Okay, so let's see the answer. So you can use this formula also beside rolling the lines. So you can use the formula n2 minus n1. So means this n2 minus this n1. 5 minus 1 you get 4. So you get 4 answer. So very good. So those who have answer correctly.
Yeah, Bun Long Lim said for lemon series. Yes, this is line series. Because
Yes.
the n1 is 1. So from 5 to 1 is lemon series, 2 to 1 to lemon series, right?
Yes. Yes.
Vivi?
Yes. Okay, so very good. So you can roll 4 lines. Okay. So here. Okay, so remember to roll the spacing getting smaller. Okay, if they ask you to wrong. So this one is just need you to calculate the number of lines. Okay. Now we look at this question. So this one for Lyman series. Okay, calculate the number of lines formed for electron transition between n1 equals to 2 and n2 equals to 5.
So then you can use formula. Formula from
Yes,
teacher
you can.
Vivi Lau.
Well, you have to be careful. So it has is they didn't mention.
But this one is calculate the number of line.
Yeah,
Number.
this one is the number of lines, so you must be careful. So any answer from the students?
Let me see. The question from Chung Zuoming, all the
Yes.
three or only layman? For question number
Because the question didn't mention Lyman or what, no? So you have to consider all the series, okay? All the possible series.
okay.
So that's why I show the two questions because it's similar.
Between n equal to 5, that's mean from 5 to 2, right? 4 to 2, 3 to 2, and maybe from 4 to 2. Is it like that, teacher Vivi?
Yes, you have to consider all the series, very good.
All okay, all three series. So
Okay,
how many lines?
So what are the answers you have now?
Chung Zuoming 3.
Okay, any other answer?
Subashini 3, Muhammad Iqbal 3, Chong Shin Chua 3. And then Chung Zuoming, then should be 6.
Okay, no more answer.
The question with question mark.
The question is question. Okay, so we have to consider all the series. So no more answers on the channel.
I think no.
Okay, so we look at the
Many of
solution. So you can use formula, you get 3 for the normal series one. Okay, but you have to be careful, you have other series. So you can roll up. Okay. So 5, 4, 3, 2, 1. Okay, so we just roll between 2 and 5. So this one is for the Bauman series. 5 minus 2 is 3. So for Bauman series, you have 3 lines. 5 to 2, 4 to 2, then 3 to 2. Okay, then you can have other series. Because the question didn't say Bauman. Okay, so you can have 5 to 3, 4 to 3, and one more, you can have 5 to 4. Okay, so means the ground state can be, the first ground state is 2 for normal series, then the second ground state is 3 for the Passion series. No? After normal is Passion. Okay, then the third one is 4, so this is
bracket.
different reason. Okay.
Yep.
means you
bracket.
have to take 3 plus 2. Okay, means 3 is from the Baumer. 3 is from the Baumer. Okay, then you consider the 2 from the Passion. Then another one is from
Bracket.
bracket. Okay, so because not in the Stpm syllabus, so it's bracket series. Okay, so we have 6 lines. So anyone answer correctly?
Only one, I think.
For one,
Chung
okay.
Zoning. Chung Zoning. But the answer is question mark.
Okay. So anyone have problems with the answers here? Can understand or not? Okay. If you have problems, you write in the comments. Okay, so we look at, so we have to find all the possible series. Okay, next we look at question number 6. Okay, so here I already draw. Okay, so you can see the 6 lines. Okay. Okay, question 6.
There is a question from Chung Sing Chua. How do I know? How do I know I need to consider all 3 series or just Lyman series?
When the question didn't mention, specifically Bauman series, then you have to do all the 3.
Maybe you can show the question number 4 again.
Okay.
Question number 4.
I show the number 4.
Yeah. Question number 4.
This one is between N1, 2 and N2, 5.
This one is calculate the number of line form for electron transition. Number 4. Question number 4.
Question number 4. Okay, so this one is between this one and
this one is between.
So you have to specific the Lyman series and 1 equal to 1.
So the keyword is between.
Yes.
Between. Okay.
Okay, so we look at question 6.
Ras, why is it 3 plus 2 plus 1? Okay.
The
question number 5. That one is question number 5, I think. Why is it 3 plus 2 plus 1? Maybe you can show the answer from the PowerPoint. Okay.
3 plus 2 plus 1, because we consider all the series. Okay. So we have to add up all the lines. Okay. So 3 plus 2 plus 1.
The first 3 line actually is Lyman series. 2 to 2.
3 line is normal series. So you return to 2. Normal series.
Yes, Balmer series. Balmer series we have 3 line. Right. For Haras, Balmer series we have 3 line. 3 to 2, 4 to 2, and 5 to 2. And then the 2 is past tense series. 4 to 2 and 5 to 4 to 3, 5 to 3. And the one is bracket 5 to 4, only 1 line. So that's why 3 plus 2 plus 1 equal to 6.
So we look at the question number 6.
Number 6.
Okay, so one of the lines in the spectrum of hydrogen atom has a wave number of 7.80 times 10 to the power of 5 per meter. What is the frequency of this line? Given the light speed of light, 3 times 10 to the power of 8 meter per second. Okay, so anyone, so try to write your answer in the comments. We'll calculate first. So here is wave number. Remember what is wave number?
There are question, what is the difference between 3 and 4? But I think we can answer it after it. Okay, question number 6 first.
3 and 4.
Question number 4.
Question
4
number
and
4 and 4. 4 and 5.
4 and 5. 4 and 5, I think already given the answer. Look at the keyword. Number 4 is between,
Okay.
right?
And the
Vivi
5
Lau?
also has the word between.
Hmm.
Only I noticed.
Okay, question number 6.
Okay, so maybe question number 4 and 5 not very clear, sorry. So maybe we have to don't worry, in the STPM exam, the examiner will set the question very clearly. So if the question come out for number 4 and 5 now, not only I notice this one also have between, 5 also have between. Question number 5 also have the word between. Okay. So the
Between.
question to be more clear, to be clearer, is to state all the possible lines from they must have the keywords. All the possible lines from okay, to be
Right.
but I think that must be the okay, sorry. So I didn't notice the question. Okay, so don't worry, in the STPM exam, the question is very clear. Okay. So we look at question number 6 now. So any answer from
Okay.
the students?
Okay, answer from GDDJ. Okay, 3.72 exponent 13.
Okay,
3.7
so
exponent
any
13.
other answer?
2.34 exponent 14. Darshini Satya.
Okay. Okay, so now we look at the answer. Right? So wave number, you have to use the formula. Right? Wave number equal to 1 over wave length. Okay. So you will get 7.80 times 10 to the power of 5. So you substitute into the, okay, sorry, this one is 10 to the power of 8. Okay. Into the formula, F equal to C over wave length. Okay. So means you take F equal to C multiplied by the wave number. So we multiplied by the wave number. So 3.0 times 10 to the power of 8. So this one is power. Times 7.80 times 10 to the power of 5. Power of 5. Then you'll get 2.34 times 10 to the power of 14 per second. Okay. So I heard just now got one student answer correctly, right?
Yeah.
Very good.
Go Min Chai.
Okay, very good. So we look at last question for today.
Without the unit.
Without the unit. So must mention the unit. Unless the question mention state the value of the frequency. Okay. If the question asks what is the frequency or what is the energy, you must always write the unit. Okay. So we look at the last question for today. Question number 7. So the diagram below shows the first 3 series of lines obtained when an electrical discharge tube, so have a tube here, sorry, is applied on a sample of hydrogen gas. Okay, electrical discharge, no need the tube. Okay, electrical discharge is applied on a sample of hydrogen gas. So here are the 3 series of lines. Okay. So the question, name the series of lines represented by B. Okay, so we look at the B here. Okay, so B is here. So you name the series represented by the B here. What is a series?
Muhammad Iqmal. Unit is hertz. Actually, hertz equal to per second. That is question number 6.
Okay. Frequency has, but for the here we use per second. Okay.
Okay, Boon Long Lim said that Balmer series. B is Balmer series.
Okay, very good.
Chung
So
Zo Ming also Balmer series.
normal series. Okay, correct. Okay, then we look at the next question. State the part of the electromagnetic spectrum in which series B is formed.
Yeah.
That
B,
means
Balmer series.
the region. Okay.
The region of Balmer series.
Yes, the region.
What is the region of Balmer series, student? Region from Balmer series. Please answer on the chat box. Balmer series. Electromagnetic spectrum. But series in Balmer. Visible light. Okay, Chung Zo Ming. Answer is visible light. Muhammad Iqmal, visible.
Any other answer?
Only 2 right now.
Okay, very good. So Balmer series is in the region of visible light.
Darshini Satya. Okay, Chung Sing Chua. Okay, good.
Okay, very good. So next question, sketch a label energy level diagram to show the electron transition for the frequency 3.29 times 10 to the power 15 per second. So you can see the diagram just now. 3.29. Okay. So you have to sketch the label energy level diagram to show the electron transition. So this one has 2 marks. Okay.
How do you want to sketch?
Okay, you don't need to draw on the chat box. You can just draw on your paper. Then I show you the answer. Okay. Next, you have to calculate the energy of the light emitted with the frequency 3.29 times 10 to the power 15 per second. So you have to calculate the energy. Remember the formula of the energy?
Teacher Lau, maybe
Yes.
you can, because we are running out of time right now.
Oh, okay, sorry. Yeah. Okay, so now I show the answer. Okay, so normal series correct. One mark. Visible light region. Okay, so you have to sketch the energy level diagram. Okay. So from the 3.29, okay, so 3.29 just now must be 6. Okay, you have to look at the question again. Okay, so I see it has 1, 2, 3, 4, 5 lines. Okay, so means you have to, okay, 6 to 1 lines, 5 to one line, 4 to 1 line. So means you have to have 5 lines. So this is a 5th line. Okay, so the highest one, highest energy level 61. Okay, you also can write infinity. So the marks is 2 marks. 1 mark for the correct label of the energy, label the energy, and label the n equal to 1 until n equal to 6, must label. So 1 mark. Then another mark for the line transition from n equal to 6 to n equal to 1. Or infinity also can have 2 marks. Okay, then the last answer, so you use the Planck's equation, delta E equal to h nu. Okay, so you will get 6.63 times 10 to the power negative 34 times 3.29 times 10 to the power 15. So you will get 2.18 times 10 to the power of negative 18 joule. So, Cikgu Shannon, any student answer the A4 correctly?
I think no.
No yet. So it's okay. So you straight away use the Planck equation. So 1 mark for the formula. Normally, like for 1 mark for the formula. Or sometimes you write substitution. They also give you mark. Okay. Okay. Then final answer with the unit 1 mark. Okay. Okay. So that's all for the lesson. Okay. Summary. So summary for today's lesson, you should have learned. Okay. Okay, you have to learn how the formation of the emission line spectrum using the Bohr's atomic model. Then you have to know how to draw the energy level diagrams and how to use the Planck equation to calculate the energy and state the different series of line. Okay. Okay, so that's all for the lesson today. So thank you for your time. Okay, please subscribe and like and share if you like the video.
Okay, terima kasih diucapkan kepada teacher Vivi Lau. Kita sudah selesai kelas kita pada malam ini. Tahniah diucapkan kepada semua yang sertai bersama teacher Vivi Lau dari awal hingga akhir. Anda memang yang terbaik. Sebelum kita tamatkan sesi kita pada malam ini, mohon tutup ruangan chat dan klik butang subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas kelas yang seterusnya. Sekiranya apa yang dipelajari bermanfaat, sila klik like dan share pada rakan di media sosial. Sila type dan di ruangan komen dan sebagai tanda terima kasih kami akan memberikan link sijil. Okey, link sijil telah pun diberikan. Jadi saya akan berikan kata laluannya. Kata laluannya ataupun passwordnya ialah #kelas AYU didik semua huruf besar. Okey, saya ulang. #kelas AYU didik semua huruf besar. Sila ambil perhatian, link tersebut akan tamat tempohnya setengah jam selepas sesi live ini berakhir. Pastikan anda menggunakan email e-didik sahaja. Okey, untuk mendapatkan info terkini, semua dijemput untuk melayari www.academyyoutuber.com. Diharapkan kelas tuition percuma ini dapat disebarluaskan kepada semua pelajar-pelajar dan guru-guru di Malaysia. Usaha ini adalah hasil gabungan guru-guru seluruh Malaysia untuk semua pelajar seluruh negara. Semoga kita semua mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat, #bermula percuma selamanya percuma. Jadi rasanya itu saja untuk kali ini. Jadi sekian. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera.
Tuition online percuma.
Selamat
Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi YouTuber.
dibawakan kepada anda oleh Akademi YouTuber.